Hi, Assalamualaikum to my lecturer and my fellow friend. Today myself, Nur Mara binti Zahrudin, with lecture number 207342, will explain or talk about my mini project of simple system design about the impulse and momentum in playing golf. Okay, this is a short video that the driver hit the golf ball. Basically in golf, the golfer will hit the ball. There are a lot happen during the collision or the impact, such as we can find the impulsive force and the coefficient of restitution. In short, we call it COR. But usually, for some people and even the golfer itself didn't put dynamic concept while playing the golf. So now I will show you the dynamic concept in playing golf. Okay, this is the free body diagram that acting on the golf ball. There's a normal force, weight, and the force that ball accept from the driver. But later in the conclusion, we ignore the normal force and the weight due to small magnitude. This is the impulse and momentum diagram. As you can see, this is the initial momentum for the ball and the final momentum for the ball, and this is the impulse. Okay, calculation that I want to show you is about average impulsive. How to find the average impulsive force, velocity at x-axis and y-axis after the impact, linear momentum, and the COR. Okay, how we can find the average impulsive force? Okay, we already have the information about the time, about the speed of the ball and mass of the golf ball. So we can apply the principle of impulse and momentum. As a reminder, the mass must in kg. Okay, the 30 m/s is the final speed for the golf ball. After we calculate, we do the math, and we will get the average impulsive force. Next, we find the velocity at x-axis and y-axis after the impact. We already have the angle, the 45 degree. So find the velocity at x-axis and y-axis and the momentum of the ball after 1 second. So we use the integrating into a seal. We can find the Vx and Vy. We use the math, and we will find for x-axis and y-axis. For the final velocity, we can conclude like this. And for the linear momentum, we can use the formula L equal to mv. Okay, mass in kg. Okay, and we use the V that we get from the final velocity, and when we do the math, we must use the velocity after the impact. Okay, because we want to calculate the linear momentum, so we use the final velocity. Okay, next we will want to calculate the COR, coefficient of restitution. Okay, this is the mass of club head. So if you want to find the COR, we must know the final velocity of the club head, because this information we didn't have the information yet, so we must find the velocity of the club head. We can use the formula of conservation of momentum. Okay, this is the initial momentum of the club head. This is the initial momentum of the ball. This one is the final momentum of the club head. This is the final momentum of the ball. When we do the maths and we get the answer, so we can apply it on the equation of the COR. For the final velocity of the ball minus the final velocity of the club head, and we divide the initial velocity of the club head minus the initial velocity of the ball. So we do the math and we will get 0.41, and didn't have the units, okay, because the unit will disappear. We will cut the unit. Okay, from the project I got a lot of things, such as I got to know that a lot of things in life, even a small thing, we can relate it with dynamic concept or the kinetic concept. And I want to tell you that by knowing how much force you apply on the ball, you can become a good player, and for surely not doing the illegal hit by hit over 0.83 of COR, because if you hit the ball over 0.83, you will make the illegal hit, so be careful. So you must know the force that you apply, the velocity you should apply on the ball. Okay, that's all for me. Thank you.